Thanks everyone for being here. So yes, we're excited to get to roll out our project, Making Smart Tools Work for Everyone. And our focus on this project is on blue-collar work. So we're focusing on making blue-collar work better. And so that doesn't mean AI replacing human workers. We're hoping that AI is going to augment the capabilities of human workers. So we're looking for ways that AI can benefit blue-collar workers. Of course, in manufacturing, construction, maintenance, and utility work, there are many blue-collar workers who do essential work in the workforce. We want to give them better, smarter tools to help them do their work more safely, more efficiently, and better. So we want to empower them with sensory and knowledge inputs and improve their work and their quality of life. So smart hand tools, as we are embarking on this project and beginning this project, we're envisioning smart hand tools that improve worker training. So they'll accelerate on-the-job training. They'll also facilitate knowledge transfer among workers, so workers will learn from each other with the embedded intelligence on the tool, communicating with other tools, as well as with the digital twin, sending input back to the worker, giving them feedback on how they're performing their work. That can broaden participation in the workforce. It can expand the range of abilities of workers. It can take sensory inputs from one modality, turn it into another modality to expand access to the workforce, and specifically can especially assist workers in adjusting through the aging process, which of course has many different impacts in terms of sensory and other aspects of work. And also improving worker safety. So giving workers just-in-time feedback that's going to help them avoid workplace accidents as well as reduce repetitive stress injuries. So the research questions we're embarking on in the define, evaluate, build mode of good systems. First, what would it mean for AI to augment the abilities of blue-collar workers rather than replacing them? Secondly, how can the alignment of smart hand tools with workers' abilities and values be evaluated? How do we make sure that they are aligned? And the third is, how can we develop a participatory design process that results in smart hand tools that empower blue-collar workers? So our first case study on the social science side has been on Longhorn Racing. This is a collaborative student organization. They build combustion, electric, and solar cars and competitively race them. They're using a number of different tools in this process. So we did 14 semi-structured interviews with student workers at Longhorn Racing about their use of tools in their work in Longhorn Racing, and we analyzed them using thematic analysis. So I'll present some of the themes that we have found through our initial analysis of these 14 interviews. Some specific challenges. One aspect is welding was a particular aspect of tool use that was especially dangerous and especially important to be able to augment. And of course, with welding, you're wearing a helmet to protect your vision, and it's basically dampening your vision, but we could always be using like augmented reality to provide some alternative view that would be more meaningful and useful to the user. So you have these challenges of the dangerous and technical setup, the limitations of the safety equipment, and difficulties in training and welding. So just some examples from those interviews. It takes a long time to set up. Most of welding is setting up. There's a lot of risks involved in it. Safety-wise, there's probably ways that you could improve. So this is what we're trying to do with smart hand tools. In terms of limitations of the safety equipment, so for example, I mentioned the visors, and some of them are permanently dampened, some of them are set to auto-dampen when bright light hits. But of course, those are powered, and if the unit dies, that can be very dangerous. If your helmet dies during a long period, if you have an automatic, you have to look away immediately. So this is part of the challenge that they face. And there's not any feedback on the unit going to die, it just dies suddenly, very dangerous. And also, everything's dark except the torch, so you're basically seeing this kind of faint blue light. And also, difficulties in welding training. So I couldn't even see what I was doing. I would take the protective mask off. It's like, oh wow, I just made a mess. Or in terms of welding itself, the actual process, depending on the position that the worker is in relative to the work they're doing. So having a different way of controlling voltage, but having that be tactile would be useful. So again, being able to modify the sort of sensory inputs and outputs, getting more feedback, having that again potentially in the actual visor that's being used, etc. So for the future of welding, how can we improve welding tools to accommodate workers' needs and values? So I'll end with a quote from one of our participants. We asked the question, what positive implications could you see emerging from the development and deployment of smart hand tools? And the student responded, I think definitely accessibility to a wider range of individuals, just because giving out data is an extra degree of personalization. So they'll make things better rather than assuming that everyone has the same capabilities. Having a tool that can adjust insights. That's what we're trying to do. Have the tool adjust to the worker, not the other way around. Have the worker benefit from the intelligence of the tool, not be replaced by the tool. So I'll hand off to my colleague, Professor Raul Longoria.
Hello, thank you, Ken. I'm going to talk a little bit about the initial prototyping and testing that we've been going through this past few months. This sketch here sort of conveys, hopefully, a little bit about what Ken has been talking about in terms of how we've been envisioning tools. I mean, we all use tools, so that's, I think, something that's very fundamental to what we all do. So we have, you think of a worker, and of course, there's a lot of talk with respect to AI in terms of robotics replacing workers, but we were thinking, and if you really look around, in a lot of manufacturing, a lot of maintenance work, we're always going to have humans in that process. And so that's what we're focusing on, is the fact that we're always going to need humans. And welding is a good example where, in fact, any kind of robotic welding, they're trying to learn from humans in terms of how they do some of these tasks, because they're very complex tasks. I think Ken showed a photo of someone hanging off of the side of a building, and this is common. Humans are always needed in manufacturing and assembly, all kinds of maintenance. So there's a process, it's complex, it's dirty, and there's a tool. There's, of course, the human controlling that tool. And so what we wanted to do was give localized sensing and maybe some help through control and actuation. We wanted to also, so the smart tool system is sort of controlling that, and of course, helping the human understand task process requirements that might be changing and communicating with the infrastructure. Understanding, so when Sherri starts talking about policy, things change, understanding how to help, not only to accomplish the task, but to understand how it interacts with the organization you're working with. So, our goal is to use sensing, to use the explosion of IoT, the Internet of Things, as well as edge AI, right, on device, right? So we're focusing really on tools are not expensive, right, and you want to keep them low cost. So we're really looking at, in a sense, doing this on device, so we can share the data and communicate back to the tool. But those are some of the constraints that we've put on ourselves. We also think about, of course, networking, not only having similar workers learning from each other and conveying how you do a certain task, but also gaining knowledge from another user with higher skill. And then also, you might have different processes being accomplished. So we kind of show this through a networked series of workers using different tools on different processes. And of course, the digital twin process is becoming very important. I think in the smart cities, they mentioned it. Also in manufacturing, it's becoming very common. How do you use models of the process, of the human, and of course, interacting with the tools? So those are some of the future directions we're going into. So in getting started, one of the things we wanted to do was take advantage of a lot of work that's been done in gesture recognition. Obviously, you're using the tool. How are humans using tools in different tasks? And of course, it's a very diverse set of tools that are being, so we needed to focus. We wanted to integrate ML, and also we wanted to focus on maybe manual and powered hand tools, right? And of course, there's always the need to accomplish a specific task. And again, this is very broad. Everybody does things differently, and you'll see in some of the examples that we did in the particular one that we chose. So actually, I started off saying, can we identify skill? And when we started working on this, we could sort of say, well, before we can identify skill, can we even identify what we're doing, what someone is doing with a particular task? So can we tell the difference between two different types of tasks? So that's where we're starting off. And so we started, well, it's the low res on the big screen, isn't it? So we started off with a real simple, a rotary power tool. Some of you might think of it as a Dremel tool. It's a nice, simple tool. It's hand-controlled. It's interacting with different bits on a workpiece, so it makes it complex. Everybody does it a little bit differently. So it was a general-purpose tool. It requires practice to get good at it. Even if you change task, even if you're good at it, you change task, you also have to learn it a little bit. So there's the ability for us to not only sort of struggle with trying to identify what's being done, but also how well are you doing it. This just shows there's a lot of overlap there, but the different tools that we use. So we decided to start off, this was just last October, a quick experiment with a simple tool like this, right? So we instrumented a tool, very low-cost device that had sensors for measuring motion, for measuring sound. We monitored how much power was being used by the tool as it's interacting with the workpiece. And the idea was to use, machine learning to try to identify, what tasks were being done. And this starts off sounding like a joke. Engineers, a sociologist, and a lawyer started. So actually, we discovered that this is one of the really challenging things about working with this project is those of us involved in it, sitting around, decided, Jose, who was managing the project, had each person scheduled to do a few hours of actual manual work. So this was tough while we were trying to grab some data, right? So this shows, there's even, Sandeep Chinchadi, who's a professor in EE, who helped us. He was the first one where we threw on the tool. He's right there in the middle. And so the sociologist is Kathy Hill, who's she's a postdoc on the project. So we had a lot of fun doing this, and it showed how difficult it is to collect data during these types. And I think that's a really important part of this project. How do we instrument these types of tools, especially when you go out and start talking to stakeholders? How do you convince them that you should use this tool, and how do you make, in a sense, the gathering of that kind of data transparent? You don't want to get in their way, so to speak, right? So a lot of real challenges there, and this was a good sort of introduction to doing that. And this just shows some examples of the kind of data that we grabbed, acceleration data, rotational velocity data, orientation, just from that real simple sensor. And we chose that specifically because it was very low cost. You're talking about instrumenting the tool maybe with about $20 worth of online microcontroller as well as onboard sensing. So we're trying to keep that, because if you think about instrumenting the tool that already costs maybe $100, $150, you don't want to put $500 on top of that. So we're trying to keep those realistic sort of goals in check as we try to also solve the problem. Okay? So we had 11 sensors actually. Things are becoming so low cost and so cheap that you can actually do that. And we started off just doing basic statistical measures. This just shows the result of random forest analysis showing how we could tell the difference between different tasks. We specified a routing task, engraving some numbers, just cutting and sanding. And by the way, there was a little bit of instruction given on how you should do this. We were almost, let's let people do it kind of how they want, a little bit of instruction. And then we just basically threw the data right at the machine learning just to see how that would work. It's not the way, as an engineer, I would do things, but we wanted to do it sort of the way you expect it to be done in the field, right? And see how well it done. And it did pretty well. The other project that we started actually just this semester, based on what we've learned about welding, not only from the interviews with the engineers working on these prototype cars, but also nationally, internationally, welding is becoming one of these jobs where there just aren't enough people doing it. It's hard to train. It's a scary thing. How do you train them quickly? So we decided to take that on as one of our principal projects. And so this just shows what the engineering design team, a senior design team, is working on. They're already looking at how to instrument a welding nozzle, some data they've already taken, doing heat analysis. So you can see a very tough task to work on. And I'm going to skip on because I think I'm taking a little bit long. So I'm going to let Sherri take over and talk about the public policy implications. Thank you.
Thank you very much, Raul. So I want to talk about some of the policy implications of smart tools, because there are many. And as we're delving deeper into this project, and thank you to Good Systems, we're finding even more. There are social and economic and technical policy implications. And I want to talk about three realms here. The first is middle skilled workers. So you heard my colleague Ken Fleischmann talk about blue-collar workers, and you heard my colleague Raul Longoria talk about that there aren't enough workers. And what we're really talking about here is a gap in middle-skilled workers, and I'll get more to that in a moment. Then organizations. There are a lot of organizations involved in the workforce that need to collaborate, co-create, work together. And then of course society. What's the effect on society when we're talking about the middle skilled worker gap, blue collar, the different organizations that need to work together, what this means for cities, for instance? So, organizations and incentives. We all need incentives, right? You know, breakfast tacos, for example. So, we have, when we talk about organizations and incentives, if we start with cities, and I see some folks here from the city of Austin, thank you. All of this has real meaning in cities. Cities, you know, are functioning with the work of many people, and these middle skill workers are really essential. And we'll talk more about some research that's been done on that in a moment. Then we have labor organizations. We're in Texas. There are not many unions. We're hearing a lot about unions nationwide right now, but there are certainly also labor organizations and professional labor societies. Industry, of course, because the occupations that we're talking about, they're working in various industries, whether it is, frankly, higher ed. If you think about the University of Texas at Austin has its own utility system here. We have maintenance workers, right? Whether it is big corporations that you may think about, auto manufacturing, other types of manufacturing, electric utilities, for instance. And then workforce training, which is essential, particularly for blue collar and for these middle skill workers. So middle skill worker gap, and there's a lot of research that has gone into this over the past decade and more every day when we see the labor shortages that we're having here nationwide, worldwide. So the Austin Metropolitan Area Community Workforce Plan, which was conducted probably about 6 years ago, I'd say by now, and it was done jointly by the City of Austin, Travis County, ACC, workforce organizations, that you see capital area. So identified a middle skilled worker gap here, and that still skilled trades cannot cover the demand and the need for collaboration among all the parties involved. So middle skilled workers, what do we mean here? Well, you've heard the term blue collar, but middle skilled workers means specifically those people who need more than a high school diploma, but not a 4-year college degree. So frequently they are obtaining some type of certification, and very often at a community college, such as Austin Community College, which I'll talk more about in a moment, or a trade school. And so that's what we're talking about with middle skilled workers. Certainly welders are part of that, and certified welders, and there are many other occupations. Then Austin Community College and the Greater Austin Chamber of Commerce had a workforce development report, and this is a quote from it. ACC is a critical partner to the region and to employers, says Mike Perrine, chair of the Workforce Development Report Task Force. We're seeing a continued increase in performance and completion, which I think is tremendous. It's a testament to the right programs with the right curriculum that our area workforce has been asking for. And this is alluding to many of the programs that Austin Community College currently has. And by the way, Austin Community College has a welding department. But Austin Community College currently has training programs and certifications with particular industries here, whether it's Samsung or others that we have seen. And so what we're looking to see is if we could amplify and continue those with Austin Community College in areas such as welding and others, and also using AR and VR and other tools to augment the training and the type of education that they are giving. So we want to assist ACC, Austin Community College, in achieving its strategic plan goals. And this was a quote taken from the Austin Community College strategic plan, which is online. When our students succeed, lives improve, the workforce is stronger, and our community thrives. And I think that really brings it all together, because what we want to do is ensure that we have a more equitable workforce, a safer workforce, that more people who have not traditionally been engaged in these occupations can be part of them. So incentives for labor, organizations, and management. For labor, smart tools is an alternative to robots. We're not talking about replacing people, because these are occupations that actually need people. But we want, again, to open up that workforce, whether it's to underserved populations or graying or people who have particular issues they're dealing with, maybe with some physical limitations, and put AI in the hands of workers to make it safer. Then, on the part of the employers, because we have to think about what's the incentive for the employers. Enhanced safety, increased safety means less turnover, fewer claims filed. This is an advantage. Enhanced productivity, of course, and inclusive work, which is on the minds of many of our big companies these days. So policy intervention goals: improve safety and conditions, improve training, increase productivity, increase diversity, and close that middle skills gap. Now, how did all of this come to me? Well, a few years ago, you may recall, we had a really big storm. And many of us, including myself, were without power, without hot water, without electricity, in my case, for a week. And I live in an old neighborhood that has, those above ground power lines. And once the power came back on, I was sitting one day working from my home, looking out and thinking, wow, this is really dangerous work that we're going to see the Austin Electric Utility, which happens to be owned by the city of Austin, so those are employees of the city of Austin, doing. But this is work that we need people doing. OSHA does not require that electrical power line clearance be accomplished by electrically qualified employees. This is a fact. So how it came to me, this is just one of the areas of how do we make this safer for the human beings who are going to continue to do this work? How do we make it safer for them? How do we make it more effective and increase productivity? And from the standpoint of this particular employer, which is Austin Energy, the city of Austin, more effective and efficient for them with fewer accidents and better outcomes. So with that, we have many collaborators on this project, and you can see them here, but one of the things that I think is so gratifying about Good Systems and this project is you can see how interdisciplinary this project is and how we have folks from all over campus who are participating. We do want to thank in particular some of our Smart Tools team members. I won't read their names, you can see them here, and many are in the audience, as well as the lawyer, Pablo, who is a lawyer but getting a degree from the LBJ School of Public Affairs. I mention him because he was the lawyer in that particular photo that you saw. So thank you to our collaborators and funders, of course, Good Systems, thank you, Microsoft, and to the School of Information, the LBJ School, the School of Engineering, and all the others who are participating. With that, do we have time for a few questions, Sam?
We do. About 5 minutes for questions. Okay?
I'm on my way.
I made my time.
Yeah, that was really interesting from all three of you. Excellent presentation. So, Sherri, I guess I'd like to ask sort of a broader sociological question. But clearly, if something like this happens, it will benefit these blue-collar workers or these middle school workers. So, will that take some people and improve their situation relative to the mean, and so they will end up with higher salaries or something like that? Or will this just lift everybody up and they end up making the same paltry salaries they did before relative to the broader community? So I don't really expect you to answer that. It's just it's the question that arose in my mind while I'm listening to you.
So I'm doing the three-dimensional chess as you're asking that, because there are a lot of factors that go into salaries, right? Supply and demand, which we are seeing right now, and we're seeing that labor, frankly, right now has increased bargaining because of the lack of supply and the demand. So you have to figure that in. But certainly, we're hoping that this will lift everyone's boat up and increase certifications, increase supply. And typically you'd say, well, if you're increasing supply, wages will go down. But I think not if you have more expertise, right, and lift everyone up.
Yeah, and actually, if I could add another great point onto Sherri's great response, Craig. So I would say that also part of what we're doing is trying to preserve blue-collar work. And there's a lot of talk of like the post-work economy. And that sounds great if you've got a luxury yacht that you're going to deconstruct an entire European bridge in order to get it through. You have your vanity rocket ships going into space. But for blue-collar workers, that's a really scary prospect. So, first of all, just retaining and continuing, as Sherri's pointing out, given like what we're seeing now with the supply and demand of labor is there is an appreciation for the importance of what these workers provide. That can be increased through, augmenting their abilities through smart hand tools, or they could be replaced by robots. We much prefer the former to the latter.
Absolutely.
Hello, I'm a student. I'm a master degree in high school. I have a question about the topics because these smart tools can be applied to the real scenario, and they are aimed to help the workers to improve their productivity. So, is there any? Because with the data gathered from the real scenarios, is there any concerns about managerial surveillance, something like that?
Yeah, it's a huge issue. So,
One we've discussed, yes.
yeah, I mean, this is happening already, of course.
Right.
So,
Your emails are not private, just saying.
yes, and the big box stores and the major shippers like handing out devices to folks and using that to track their every move and bathroom breaks, et cetera. So this is a huge issue generally. This is something that we're considering. Our goal is to give the workers as much control over their information as possible. Mm-hmm. So part of this is in terms of the surveillance, in terms of efficiency and that kind of micromanaging. Another aspect is this is actually their intellectual property. Mm-hmm. This is their skill.
Right.
That's what they have to market. And of course, in the apprenticeship relationship, there is a skill and knowledge transfer, but it's a voluntary one. So we want to keep that a voluntary one controlled by the expert middle skilled person rather than to hand that off automatically. So, but Sherri, you probably have more to.
Well, no, I just want to add that this is a key question and concern and one that we do have a laser focus on. Yes.